everyone, in this video let's discuss about the SR flip-flop in electronics. So first let's write the block diagram, next circuit diagram, truth table, characteristic table, and in the fifth step we will be writing the excitation table. So first let's start with the block diagram. In all the types of flip-flop, we will be having one common input, that is clock. So clock will be the common input in all types of flip-flop, whether it may be delay flip-flop, toggle flip-flop, SR flip-flop, JK flip-flop. In all types of flip-flop, clock will be the common input. So first one is S and second one is R, and clock is my common input which I will represent using CLK. So yes, clock and R are my inputs. In flip-flop, we will be having only two outputs that will be complement to each other. You can use any letter to denote it, A bar, B bar, like that. So what it will do is, if one output is 0 and another output must be complement of it, that is it must be 1. If one output is 1, its another output must be equal to 0, that is complement to each other. Same output must be not written in the flip-flop. So now let's write the circuit diagram. So to write the circuit diagram you can use NAND gate or NOR gate. Let's use the NAND gate itself. So first let's design the latch, then later let's design the flip-flop. So how to design the latch? Two NAND gates are used and output of one NAND gate is provided as input to another, and output of another NAND gate is provided as input to another. What are my outputs? Q and Q bar. Now we designed the latch. Now let's design flip-flop. To design flip-flop, we will be adding another two NAND gates in front of them. So what are my inputs? S, R, and clock is my common input, which value will be always equal to 1. That is IR. It will be always on, not it must. It will be always on, it won't be off. Now using this circuit diagram, let's write the truth table. So what are my inputs? S, R, and no need to write the clock input, because clock input value will be always equal to 1 and it will be always on, so you can neglect it. And my output will be Qn plus 1. What is Qn plus 1? Qn plus 1 means present state output. Qn plus 1 means present state output. If you see, I am having two inputs, S and R. So what will be my combination of inputs? 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. Short trick is 2, 0, 2, 1, 0, 1, 0, 1. Like that. So what will be my output? When both S and R value will be equal to 0. That is, when there is no input given to the flip-flop. When both the values will be equal to 0, you can consider that no input is given. So what will be my output? Previous state output will be the output in this previous state output will be the output here. If you see, Qn means previous state output. And 1 are not valid in SR flip-flop. 1 and 1 are not valid. Both the S and R inputs cannot be equal to 1. Next, when S value is equal to 1 and R value will be equal to 1, just write S value, that is 0. When S value is equal to 1 and R value is equal to 0, just write S value, that is 1. Simple. Now using this truth table, let's write the characteristic table. It will be much larger, so I not wrote the excitation table at the starting. Let's write it later. So how to design the characteristic table means, we will be having three inputs right here. One will be S, second will be R, and third will be the previous state output, that is Qn. What will be my output here in the characteristic table? Qn plus 1, that is present state output will be my output. Since I am having three inputs right here, what will be the possible combination? 0, 0, 0, 0, that is 4, 0, 4, 1, 2, 0, 2, 1, 2, 0, 2, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now, when S and R value, both value will be equal to 0, output will be the previous state value. When both S and R value will be equal to 0, output will be, present state output will be equal to previous state output, that is 0 and 1. Just copy them, 0, 1. When both the values, that is s and r value will be equal to 1, it is not valid. So not valid means cross mark. When s value will be equal to 0 and r value will be equal to 1, just copy the s value, that is 0. When s value is equal to 1 and r value will be equal to 0, just copy the s value, that is 1. So this completes the characteristic table. Using this characteristic table, let's write the excitation table. Here in this excitation table, we will be using the present state output and the previous state output as my inputs. So Qn and Qn plus 1 will act as the inputs. S and R will act as the outputs. Qn and Qn plus 1 will act as inputs and S and R will act as outputs. Since I am having two inputs, what will be my possible combinations? 0, 0, 0, 1, 1, 0 and 1, 1. 2, 0, 2, 1, 0, 1, 0, 1, like that. When Qn value is equal to 0 and Qn plus 1 value will be equal to 0. Search here. Qn value is equal to 0, Qn plus 1 value is equal to 0. Qn value 0, Qn plus 1 value 0. Any other possibilities? No. Here if you see S value is 0, here also S value is 0. It is not varying, so you can write 0. Here R value is 1, but in this condition R value is 1. Here R value is 0, but in this condition R value is 1. 0 and 1. R value is varying, so you will write not varying, that is cross mark. Now search for 0 and 1. Qn value will be equal to 0 and Qn plus 1 value will be equal to 1. 0 and 1. Only one condition is there. So S value will be equal to 1 and R value will be equal to 0. S value 1, R value 0. Next, when S value will be equal to 1 and next, when Qn value will be equal to 1 and Qn plus 1 value will be equal to 0. So 1 and 0. Whether another possibility is there? No. S value is 0 and R value is 1. Next, when Qn and Qn plus 1 value, both value will be equal to 1. Here is one condition and here is one condition. S value is 0 here S value is 1. S value is varying, so not valid. R value is 0 here and R value is 0 here. So in both the condition, R value is equal to 0. You can write 0 here. Now we completed all the steps in the SR flip-flop. So hope you understood the concept. If you have any doubt regarding this topic, please do comment below. If you liked the video, please subscribe and support us. Thank you.